Okay, so we're starting this ILM, Grades and Elevations, Part B. And this is going to lead us into our shop class as well for builder's level. These are some of the things that you need to know to complete this shop class, and that's why we're going through this ILM next. So the objectives and outcomes on here. Listen, they even kind of say drainage and venting systems do not work unless we have sufficient grade, because we use gravity to take away all our waste products. As plumbers and gas fitters, this is pretty critical stuff. We need to get the grade correct, or else we're going to have some problems. Now, we want you to know where to find this information. And the last ILM that we did, we had that plot plan that had all of those elevations on it. And this is to help to determine where all of our physical job measurements are. So the objectives today, we're going to talk about and identify various types of builders levels, list and describe the terminology associated with that, and describe the use of builders levels to determine prescribed elevations. And then in shop class, you, with a partner, for your builders level shop class, we are going to do site shots around a particular building. Now, we will go rain or shine, by the way. That's something that we'll do regardless. And we have builders level Monday, Tuesday, Wednesday. And if you look at my phone, there is the weather forecast for Monday, Tuesday, Wednesday. So not too bad. Whoever has me on Monday for builders level, well, happy day, you scored. Tuesday, still quite warm, maybe a chance of showers. Wednesday, a little cooler. So we'll talk about that in our JHA of what we need and to prepare for because we're going to be outside. So there it is. Okay, introduction. Grading and plumbing systems is probably one of the most important tasks in this trade for grading of sewer pipes, and it can't flow without proper grading. And of course, we have to support it properly, right? Sometimes the weight of the contents may cause that pipe to not work properly. So that's also very important. Okay, and then neither grade nor pipe supports can be determined without having this proper elevations to start. And they even say in here, if you don't get this right, it could be costly. This is why we're here. We're here because we need to make money. We don't want to lose money. So this is super important, not only to us, but to your boss. All right. So objective 1, elevations and leveling. Levels and builders levels are used to determine or transfer elevations. When they're set up, levels establish a horizontal plane. So this is a level. There are two types of levels. One is optical and one is laser. And so these are just trying to give us a certain starting point. These measurements can be compared to a known elevation, such as a benchmark, a previous shot, sometimes called a datum point, with a geodetic elevation above sea level. And then that way we can determine if things are level. And now here's a picture. So we have a benchmark. This is known elevation. These are always known elevations, a benchmark. And then after we have a known elevation, we could take other shots to determine their elevation compared to the known elevation. Now, optical lasers will give you the levels that we need. So as you can see, the optical laser will run and it will give us a perfect level line on a wall, etc. And then we could have little indicators telling us if we're high or low as well. But these are nice to have, very expensive machines, but they're nice to have. And we'll actually preview a couple of these, or at least one of them, in shop class. Now, optical levels. And basically what these are telescopes. They're small telescopes on a tripod. But these levels require a person at the instrument to sight through the telescope. And we need a person with an elevation on a rod. This is the second person. And that rod that they read is basically a tape measure, right? That's all it is. It's just a tape measure with numbers on it so we can determine what or height it is from the bottom. That's all we're doing, really. And these ones go 360 degrees, which means you can turn them around 100%, right? You can look at anything around. Now, those are optical levels. Next, we have this dumpy level. And listen, I wouldn't call it that, but that's what it's called. I don't make up these names. A dumpy level can be used for accurate vertical measurements up to 100 meters, which is pretty far. Okay, they're highly sensitive and they need to be level. All of these need to be set up on a level base. Okay, and we level these up. As you can see in here, there's these leveling screws. So once you get your tripod set up as close to level as you can, then you will use these adjusting screws to level your telescope, so to speak. And you will have a bubble in here and you will level that according to that bubble, and you want to get it right in the center. And we can do that. It's tougher when it's cold outside. Trust me, I've done this outside in the cold, cold weather. Now, when you look through the telescope of a dumpy level, you will see horizontal and vertical crosshairs. Now, and if I drew a circle here, you will see this stuff in there. Vertical and horizontal crosshairs. This is where you want this to do, right? So the eyepiece must be turned so that it is over two opposite leveling screws in here. We're not going to use the dumpy level actually, but we just want you to know what it looks like. And then you position it over the other leveling screws. So you turn it, you turn the top until you're back over the other leveling screws, and you check it to make sure you're still level at a 90-degree turn, right? We just want to make sure it's level all the way around that 360 degree. Any questions so far? Builder's level is what we will use. We will be using these builder's levels in conjunction with a target rod, tape measure, and not a stick. We're not going to use a stick, but you can use a stick if you need to, like a piece of wood, 2x4. But 2x4s are too expensive these days. We're not gonna use 2x4s. So first thing you do right here, set the tripod up in the location close to the area of intended use and not in traffic. We will not set up any of our builders levels on any roadways where cars can, or you can interfere with the flow of traffic. When we are on site at SAIT campus, you must be on sidewalks or other walkways, that you are not to be on any roadways at all. So we're going to then, first off, level the tripod head by eye, and that's the tripod, that's the 3 legs tripod, and then you're going to then level the builder's level. Return all the thumb screws to the halfway mark on their posts. Rough level by raising or lowering the tripod legs as needed, and then you fine tune the instrument to get it level. Now, at this point, the automatic level is ready to use, but the tilting level requires further adjustment. Sometimes this tilting level is also referred to as a split bubble, and it must be adjusted. Failing to do so, you can lead to errors. Now, the split bubble is used to make fine adjustments when required when using a tilting level. When you sight through the eyepiece, you will see this bubble here. It's on this next thing. You will see this bubble right here. And this bubble has to be looking like this. This is correct. This is wrong. As you can see, if you're off by this much, you're going to get a wrong reading instead of the right reading. Okay? When we are in shop class, you will get to use this builder's level, and we'll figure this out a little bit. It's really hard for me to just say, do this, do that, without having something in your hands. And we're going to have that in your hands, and we're going to kind of guide you through how to look at this correctly. Okay. Well, then they give you another list. 4, focus on the target, adjust the split bubble to make sure it's level, record the measurement from the rod or tape, and after you sight a new target, check the split bubble and readjust if necessary. This split bubble, if you have one that has this split bubble, it has to be checked and adjusted before every shot, always, okay? And then they talk about fine adjustments. Now, sometimes we have these automatic builders levels, which will automatically adjust and level for you. And they will compensate up to about 12 degrees out of level, these automatic levelers. There's a kind of a compensator in there. Okay, and it actually does your fine tuning or fine adjustments for each shot, and it does that by itself, which is kind of nice. So this automatic level in figure 10 has a mirrored mounted so to reflect the image. So this is the downward, but this has a mirror on it showing you that it's not level. So you want the bubble within the circle. You want the bubble in the circle to tell you it's level. When you look through the eyepiece, you can find what's called stadia lines. This is a stadia line, this is a stadia line, and these are crosshairs. This is a common feature of these optical levels on the stadia lines. They're not super accurate if you're trying to, the distance indicated right here, the distance indicated between the stadia lines can be multiplied by a factor of 1 to 100 to estimate the distance. So if you have a person standing here with a rod in his hand, you will see measurements on that rod. So in between, if you have it up here, in between this, you can estimate that that's a 1 to 100 difference, and you can estimate how far it is from there to you. It's an estimation. It's not exactly accurate, but you can see that when we get to shop class. So if you are determining distance using these stadia lines, it's only acceptable for operation where precise measurement is not required, okay? That's what they're trying to say. It's not super accurate for distance. Now, as you can see, this is the use of stadia lines to determine that distance. So this goes between 2 units of 100. So the estimated unit is 200. If we're using this as 1 meter, that's 1 meter of distance times 200, then it could be 200 meters. This is 200 meters in there if you're that far off. So that's all. It's not a big deal. We're not going to do much of that at all. And then we get down here where 2 people are required when optical levels are used. And we are going to work in partners. So you will have a partner to do for this shop class. We'll talk about more about that when we do a JHA. So the rod person holds the target rod or stick or whatever it is that you're using, tape measure, over a point which the instrument will be aimed. The rod must be held plumb. So some of these rods that we will use have a little level built into them. So you want to make sure that that's level when you're holding that rod. If this is you and you're holding this, you want to make sure it's level. If a marked or graduated target rod is used, the instrument operator, that's this guy, the instrument operator, reads it through the scope and records the data. If a simple stick is used, such as a length of 2 by 2, some hand signals will be required to direct the rod person to move a pencil up and down. So if you're just using a piece of wood, then this guy right here will have a pencil in his hand and he will mark where you say, right? And you'll say, go up, down, up, down. Okay, good, mark it there, right? This is good, this is lower, this is much lower, this is slightly higher and much higher, okay? There's a couple of hand signals. Now, when you are far apart from your partner, sometimes you would use a radio, right? Just to say up, down, whatever. Sometimes you could use your phone. There's other ways of communicating other than some of these hand signals. All right. We don't have to be yelling and screaming at each other over other people in the parking lot or around the buildings at SAIT. We don't need to do that. Okay. All right. Laser levels. Listen, you guys see these all the time on job sites. And these levels give accuracy, greater accuracy than hand leveling over long distances. And this is really fixed. So there's 2 types of laser levels, fixed and rotating. A fixed laser is to light a single point, horizontally or vertically, because this can change to have a horizontal line or a vertical line, right? There's usually a little adjustment in there. So you can get a straight up and down or straight vertical or horizontal. This rotating one gives you a 360-degree circle. So everybody in the room can see that. Now, as you can see down there, there's 2 types of rotating laser beams, visible and infrared. With the infrared laser, the beam is not visible, so you need a sensor. also with that, like what this guy right here is holding. He has a sensor right there, so the laser level can detect it. Right? So it has an audible signal to alert the worker if you're too high or too low. And don't look at the laser, right? Don't get it in your eyeball. It's not good. So the advantage of using lasers is you can work alone with these. As you can see, you can level off this platform with a laser level, or you can level off these pilings or whatever they are there, that sort of thing. Okay, so some of these, this one right here, some of these can be adjusted for grade. So you can say that this is 1/8 of an inch per foot or 1% grade. Some of them have that adjustment, and you tell it which way to go, and it will give you a grade. It will beep as you go along your trench or pipe with your rod here with the laser set up somewhere else. It's a decent way of doing some trench work if you're by yourself. Where's my mouse here? I think my mouse is broken. Whoop. Okay, and there it is. Now, danger, caution. Okay, if you're setting these up, put them below eye level where possible, this laser level. You don't want people to walk around and have it at like, 5'7" right in my eyes. That wouldn't be good. You're going to want to set it lower or well above, okay, eye level. Like put it at 7 feet tall or put it at 3 feet tall. Okay, so we just want to prevent any accidental shots in the eye with the laser, because this is not good. Okay, any questions? Infrared light. So this does not produce a visible red beam. Therefore, it's always required the use of a sensor at the rod location. There is no danger to eyesight with these. And then you don't need warning placards or labels, right? Fixed beam laser levels have a single beam without a rotary capability. They can be simple as handheld level with a built-in laser to project a level line or point. Okay. Plumb lines, that's all we do. And as you can see, you can get these little boxes that have, it has a vertical, horizontal, side. So there it is there. It looks like you can have laser levels all over the place. So you can give you lines on the walls and stuff so you can get things vertically correct. It's nice to have one of these on the wall if you have to drill in inserts going along or along the ceiling, right? So you get them exactly straight. That way your pipe is going to be straight, unless you put in your inserts crooked. That's different, right? That's an operator thing. So these rotary levels, these rotary levels that spin around, they spin to produce a level line or some kind of level plane of light when they're set on a tripod or other support. These are usually self-leveling. Even when you're 6 degrees off, they are accurate to about 1/8 of an inch in 100 feet. So pretty good, right? And some of these battery packs last for quite a long time. I don't even know why they do that. But these rotary levels can be turned 90 degrees to produce a vertical line, or you can make them as a horizontal line. Very beneficial on job sites. If you want things level and straight, these help tremendously. So this one here shows that you need a sensor for this one. So as this one sends a beam out, this will tell you if you're too high or too low or just right. Right? And it's really nice to have. And then you can see you could put these on a floor and you can get a wall or even on the vertical floor. Okay. Let me just look, just bend the rod. Yeah, right. Okay. Let me just pause. Ooh. Let's get back to the ILM. So there's laser levels. They help us all the time. Has anybody used these laser levels? Anybody?
Yeah, I use them a ton.
Yeah, some people use them a lot. And quite frankly, they can be super beneficial to us. I mean, they really can. They really work well. Now, and it shows here, this next page, we're on page 15 now, and it just shows that you can align your sensors with your light just to get wherever you want to be. So if that's where you want to be over here, you align it. Now, here is where you put your indicator or your instrument onto, this guy has it on a level. I mean, that's a pretty big level, but he has it attached to level, and then he has his laser level over here. So this is the detector, and he's determining the top of these footings, which is a good idea because then you get everything level. Not that we do top of footings, but sometimes we need to make sure things are level. Now, there's a couple of accessories in here. Yeah, I use a lot these in groundworks. You're right. The tripods themselves, there's attachments that go onto them. So the tripods themselves have this screw, as you can see on the bottom here, and this screws onto the instrument, and you just have to thread it in. And listen, we don't need a 2-foot wrench on that little nut on there. We don't have to tighten this down to break anything. So when you have your tripod legs, you're going to want to adjust them so you're not hunched over, right? So your arms aren't hunched over like this and that you're not bent over to look into that. You're going to want to use it as a comfortable spot. So it's going to be set up like that. So you can actually just lean into it and look at it. Okay. I don't want to see you guys bent over and this is only, 2 feet off the ground and you have to lie down to take a shot of a reading. Okay. It just doesn't make sense. And if that's the case, then you need to then go to a different location to take your back sight or foresight or whatever it is. And that brings us into target rods or whatever these target rods are. Okay, so let me just stop there for. Okay, where we left off was right here at target rods or level rods. So these target rods or these level rods are used in conjunction with your builder's level or optical level to make elevation measurements. So these rods can be as simple as a stick with a pencil, whatever, could be a measuring tape, etc. But these rods that we have, it can be either in metric or imperial. And they do not generally include fine graduations. So the operator of the builder's level, the optical level, will estimate to the nearest millimeter when viewing through the rod through the optical level, okay? So you kind of get a pretty close idea of what they are. So this is an imperial measure rod, and this is a metric. This one, put a note here, is sometimes referred to as, I can't even spell this. Let me just get the correct spelling here. Philadelphia rod for the imperial rod. I don't know why. They just call it the Philadelphia rod. And it is what it is. That's what they call it. So that's the imperial rod and the metric rod. And we'll show you how to read those correctly. So the face of this graduated rod, graduated meaning it has graduations on it, little indications of measurements, should be protected when your rod is not in use and when it's stored. Listen, muddy fingers, quickly wear the numbers down and the graduations down, making them unreadable. So your rod should be kept clean and stored to prevent from damage. It's like junior high school rules. Some rods collapse within themselves, meaning they are extended out. So they have extended from bottom up. So the unexpanded section do not cause errant readings, etc. Not a lot. Just take care of this equipment, especially our equipment here at SAIT. You don't want to be smashing it around. So as you can see, the rod should be held plumb in two directions, and that's vertically and horizontally. You want this level and you want this level in between here, okay? Sometimes they have a little circular level that clamps right to the rod so you can hold it level. Other times you're going to want to use your torpedo level and put it against the rod. So your little 6-inch torpedo level, you will level it up against the rod, and then you know if you are holding it level.
For class, are we going to need to bring a level or something like that, or we're going to have to
Listen, if
level
you
it?
want to bring a torpedo level with you, something you could have in your pocket, Brad, that's a good idea, right?
Okay.
I think it's your own. I'm not having to, supply you with anything, but I must say this. Any equipment that you bring onto SAIT campus, like a tape measure or a level, they are yours and they're yours to take care of. Any damage that happens to any of this equipment, I cannot, and SAIT cannot be responsible for that.
Right.
Okay.
Makes sense.
So I would encourage you to bring your own tape measure and your own level. Yes, of course. Okay. Nothing else. You start bringing too many tools and it becomes a little bit of a nuisance, right? We do have all the tools that you need for these jobs, so you do not have to bring anything other than your PPE. Okay. So now we get down to this figure 26 in here, and it shows some examples of markings and readings taken on a metric rod level. So as you can see, this is the bottom of the rod down here, the one on the left. And each indicator is a 1. Each little box that they have in here is, so let me just put a little box in here. Okay. So this is indicated of one of these right here, right up here. So this goes 1 and then 2. On the bottom is a 1 and on the top is a 2. And then we estimate whatever it is if it's in between it. So we go 1, 2, 3, 4, 5. And you can see now that that is 50 mils. I will get a better picture of this and we will go through this. This is just quick. So this is 5, 6, 7, 8, 9, 10, or 100. And then it tells me that I am at 100 mils on this one. So that's going to be 1.1, 1.2, 1.3, 4, 5, 6, 7, 8, 1.9, 2 is how this is read. Now, these are a little different in here. It shows you a little higher up. The red or the color change indicates 1 meter. So this line right here indicates 1.1 meter. And now they have this in the middle. So this is 1.11, 1.15, and this would be 1.2. So that's kind of how they are read. And we'll go through, I got a couple of exercises here on rod readings, so we'll have a good grasp of what that is. Now, the imperial target rod gives you a little bit different indications than the metric. As you can see, everything is in decimals of feet. There's no fractions, there's no inches. It's all decimals of a foot is what these are. So if this is 5'7", the 7 indicates the second digit. So you will somewhere have to see that this is 5 foot. Okay. And this is 5'7" right here. And this is 5'7", 1, 5'7", 2, 5.73, 7.4, 7.5, 7.6. As you can see, they just rise up 1/100th of a foot like that. Now, I want to go through some of this terminology first before I get into any of these exercises. Okay, so we're going to go through this terminology, which is pretty important. The back sight, and the back sight has, we call it BS sometimes, the short form. We know all what BS stands for. But the back sight, I want you to make a note here, is the first shot or reading. The back sight is always the first shot or reading from a benchmark or a known elevation. So the back sight is the first shot that you take all the time from a known elevation. So a benchmark here is a known elevation. Common examples of a benchmark is metal tablets set in concrete, non-movable parts like a fire hydrant, a manhole cover, or even a curb. So that is a benchmark, or it is a known elevation. Now, I want to show you something here. I'm going to... Wow, and I don't even know where I have these. Okay, that. Here, let me pause this recording for a second. I wanted to do this. So back to the terminology. Whoa, everybody's over here. Let me just push that over. So closed out the circuit. So closing out the circuit is what we're going to do in shop class. We're going to continue with from the original benchmark, and we're going to go all the way around and come back to the beginning, to the original benchmark. And what we're going to do, we have a building on campus, and we call that building the Begin Tower. And we are going to start at the shop doors of the shop of CB 102, and we're going to shoot all the way around the building. So we have to take different shots all the way around to close out the circuit. So that's what we're going to do. And there's different elevations around the backside of the building, etc. So it's fun to do, so to speak. Now, datum point is a mathematically defined reference point. Mean sea level is the datum point most commonly used in leveling. However, in some cases, it may be more advantageous to set a datum other than sea level. So this can also be a benchmark at some point. Anytime we talk about elevation, when we're talking about builder's level, it's a vertical distance above or below a given datum. Now it says sea level, but it is a given above or below a given benchmark. Foresight. Foresight is a rod reading made when the instrument is sighted towards a point of unknown elevation is the foresight. This is important. The unknown elevation is what we call a foresight, or FS. The height of the instrument. This is the elevation of the line of sight with respect to the location of the instrument. So this is abbreviated HI, right? This is FS. This is BM, and this is BS. So those are some of the little indicators of what those are. Now, a hub. A hub is usually a stake that's driven into the ground, and it's usually just an elevation that is written on that stake. This intermediate foresight, IFS, it's a rod reading made from a known height of instrument to establish an elevation of a secondary point. So this is to get a new benchmark. It says an IFS should never be used to establish a new benchmark, but that's okay. We're going to make sure that our mathematics are correct. And this is kind of how we begin to get a new benchmark or a new known elevation. Line of sight. A line along the horizontal crosshairs affected by light refraction. Okay, I'm going to add what a line of sight is. If you set up your builder's level and then you have an obstruction in there, like a wall or something, you can't see where your guy is with the rod. You don't have a line of sight to the rod. So you will have to make sure your line of sight is available for your next readings. The station is where the point, where the rod is held for reading. This is you holding the rod. This would be called the station right there. That is the station. We have these temporary benchmarks, and this is a momentary benchmark that is used only for the purpose of transferring elevations to the actual work area. This is just in case the proposed job site benchmark cannot be seen from the first instrument setup due to obstructions. So if you're digging a ditch over here and you have a pipe going on. And if you can't see it through this wall, you may have to get a temporary benchmark, and then you can set up your instrument. And so you can see your benchmark on the rod, and then you can see your elevation of your pipe, right? You may have to have a temporary benchmark. A turning point. Now, a turning point is a solid surface, so it has to be like a paved surface, a manhole cover, whatever it is, on which the foresight and backsight readings can be made. So this is to determine or how we move that instrument, because we will have to move the instrument. So the turning point is the place where we can see both the foresight and the back sight. Okay. Now, we're going to go into some basic stuff on site surveying. And it says, when you completed this objective, we're going to describe the use of builder's level to determine prescribed elevations. So in construction, listen, the surveying crew is going to come out and do the main survey work. They are going to give us a benchmark. The benchmark will be determined. We don't do that. We just use the benchmark to find and then to determine our own elevations. We don't determine this. And again, that term elevation is referred to the height of a point above or below a reference point, a benchmark, or datum. So now, once the surveyors establish a location, we can continue, or you can continue to lay out further points and reestablish a new benchmark with you during and after excavation of the property. So, as we said before, this benchmark or datum point is our starting point. This is the starting point. We always have to start at a benchmark or a known elevation. I can't emphasize that enough. Okay. So the surveyor will give you a temporary location of a benchmark for you to use near the site. So something permanent can be like a fire hydrant or a manhole cover, something that can't be moved, right? We don't want it to move. And now the benchmark is given sometimes an arbitrary number, such as 100 or 1,000 for the purposes of construction. So we can go below or above that mark, right? It's kind of like an architectural elevation. So if we go deeper, we're not working with negative numbers. That's why they give us that. So here we go. It shows in this picture, this little survey. This is the benchmark, which we start. And then this guy here is using a manhole cover for his benchmark. Now, benchmarks, or excuse me, backsight and foresight. So aiming at a target rod set on a datum. So this is the benchmark. You see here it says benchmark. That's where your initial first reading is taken. Okay? That's your first reading is always taken. And this is called a backsight. So when you turn your level, the builder's level, when you rotate it to get another view, your person with the rod goes to a new station with the rod and you take a shot from there. And this is called the foresight. second shot. All right, this is the second shot. And this is called a foresight. Woo. So it says here, when you know the backsight and the foresight, you can subtract or add them to determine how much the point is above or below the benchmark, thereby identifying its elevations. Okay, so we're going to do a little bit of that. Now, having said that, I am going to, let me just see on here. Yeah. Did I not import that? No. I thought I imported the other assignment here. I don't see it. Okay, that's okay. I can import it anyways. And here we are. So this is the assignment that I sent you guys. And we're going to determine a couple of these things. First off, we're going to read this rod here. Now it tells us how to read this rod. The diamonds or indications of number of meters. So there's 2 diamonds on here, 1, 2. So that tells me that's 2 meters. One of those diamonds tells me it's 1 meter. And so that is just an indication of what that rod reading is. And as I said before, each indication, so this is 2 meters here, then that's 2.1, 2.2, 2.3, 2.4, 5, 6, 7, 8, 9, 10. So that's 2.1 right there. So that should be 2.09 right at this location. And then that's 2.1. So that's how to read that. And then we have each is 1/10 of a foot on the Philadelphia or imperial rod. We do not use the V rod anymore. So we're not even going to talk about that.
Could you explain the E rod again there?
Okay. Well, let
Please.
me just do this instead. This would be better. Okay. This would be a little bit better. So with this rod right here, we're going to estimate some of these measurements. So for number 10, we are going to go, this is 1 meter. There's 1 diamond, so that's 1 meter, okay? That's going to be 1 meter. And then it has an 8, so that's going to be 1.8 meters, okay? And then we count up how many indications. So this point right here is 1.8, right at the very bottom. Let me make another note right there. That's 1.8 meters. So this is 1.81, 1.82, 1.83, 1.84. So that's going to be 1.84. And now you see it is just above the line of 4. So that's going to be, we estimate that, and I could say 1.842.
So every little neck, I guess, like edge of the box or shape or letter, whatever it is 0.1.
That's correct. Every box. So this is every little box is indicating 1, right? And that is that number right there. Okay. Let me just move that out of the way. So we'll count up this. So this would be one right here. This location should be 1.85. One right there is 1.86. Right there, 1.87. Right there, 1.88. Right, and then we're going to go over here. It's not quite to the 9. So this is going to be 1.888. How's that? That's pretty meters. And then at this point above it, right at the corner, is going to be 1.9. .90 right here, right there. And now we're going to go all the way up to this point. So let's count it. 1.91, 1.92, 1.93, 1.94, 1.95, 1.96, 1.97 and a half. 1.975. And then this is 1.98, 1.99. Right here is going to be 2 meters. And then we go 2.01, 2.02, 2.03, 2.04 and a half. 2.045 meters, right at number 6. 2.05, 2.06, 2.07. 2.08, 2.09, 2.1. So this location is 2.1 meters. And as you can see, that indicates the 1. This is 2 meters. This indicates 2 meters, and this indicates the 0.1. So right at this location is 2.1 meters. 2.11, 2.12. 2.13, 2.14, 2.15. Let's go all the way to the top. 2.16, 2.17, 2.18, 2.19, 2.2. 2.21, 2.22, 2.23. And that's how to read a metric rod. Now,
Doug.
okay, yeah. Let's go to a imperial measurement rod next. So we will try to read this. So this is indication right here, this small 6 right in here tells me I'm working at 6 feet something. So I know I'm at 6 feet. This down here has to be 6.5 right here at this measurement. That's 6.5 feet. 6.51, 6.5. Oh, wait a second. I did that wrong. Hang on a sec.
Would we be in 5 feet then? 5 foot?
No, this is still in 6 feet. You see, it has to go all the way down to below 1 to get it to 5 feet. Yeah.
Yeah.
Has to go all the way down. So this, because this is 6 right here, this would be 6.6, I think. Let me just 1, 2, 3, 4, 5. This is 6.65. So this is 6.5. Whoa, I'll get a little pen here. 6.5, 6.55 right there. That's got to be 6.55 feet right here. 6.56, 6.57. If it's right on that number, that's going to be 6.57 feet. Six 6.59, 6.6. Right here, this is 6.60. 6.61, 6.62, 6.63, 6.64, 6.65, and then we're a couple up, so that's 6.65. And then I can estimate that to be up, I don't know, 2 or 3. It's an estimation of what that is. So that's 6'6", 0, 6.61, 6.62. Wait, I think I jumped 1 too many here. But this right here gives me 6.7. 6.71, 6.72, 6.73, 6.74, 6.75, 6.76. Six 6.77, 6.78, 6.79, 7. Excuse me, 6.7. Oh, give me my eraser here. I even get.
Yeah, Tyler said he had some technical difficulties this morning.
Okay, that's
Said
good.
he's signing in now.
All right. Technical difficulties with this pillow. I understand. It's usually what it is. 6.76, 77, 78, 79, 6.8. Right at this location, 6.8. 6.81, 6.82, 6.83. Six 6.85, 6.86, 6.87, 88, 6.88, 6.89, 6.9 right here.
Do they always start at 6 for these ones? So
No, no, you'll start at 0. This is just giving you the middle of the rod reading. Okay, that's all it's doing.
Okay.
It's giving you some middle. 9.1, 9.2, 9.3.
Because of that 7, the way it's like different.
What do you mean? That this is the big 7?
Yeah, the big 7 that indicates 7 feet, right?
You got it.
So you know that you're at 6 feet below that.
Yes, because of this little 6.
Oh, okay, yeah.
Okay. So this is 6.9, 9.1, 9.2, 9.3, 9.4, 9.5, 9.6, 9.7, 6.97, 9.8, 9.9, and then we go all the way to 7 feet. So I know at this indication right here, at this point, that is 7.1. So one less than that for number 3, that's going to be 7.09. Thanks, Tyler. Glad you made it. And right at this location right here, I know that's 7.5, or excuse me, 1.5, right? Because this is 7.1, 1, 1, 2, 1, 3, 1, 4, 1, 5. This is 7.15. And this location then is 7.2. So that is how we read a imperial measurement rod. We have many different types of rods in our lockup for our use. You could use metric or imperial. You can choose. I really don't care which one you use on these, but those are the ones that you can use. All right, either or. Yes. And we are going to start just with some more terminology so we know what it means. So follow along. I know I emailed you this particular thing. This is still this assignment 7 that we're working on. So up here, let me just, where's my black pen? We will call this the rod. Right here, this shot right here is what they're talking about, and we will call that the BS. This right here is a known elevation, so we're going to call that the BM. This is the instrument right here, so we're going to call that the HI. This is our second shot over here, so we're going to call that the FS. And then down here at the bottom, we're going to call that the station and also the turning point. So this is the terms, and then we will actually give it a definition. The height of the instrument is the height of the center Okay, it is the height of the center of the lens or line of sight center, and it must be established before you can calculate any other elevations. It's very important. So the height of the instrument is calculated by taking the benchmark and adding the back sight. Make sure you write that down somewhere. The height of the instrument is established by taking the benchmark, and that's a known elevation, and adding the back sight to it. That's how you get the height of your instrument. Now, the benchmark, as you know, is a known elevation. And this can be calculated as well. Because once we get to this point, this can be our new benchmark. Once we get that elevation of that point, that station, right where that turning point is, we can determine a new benchmark. And what they show here is a pin in there. That's a pin. Now, a back sight is a rod reading. Shooting towards a benchmark. And that is a backside, and that has to be a known benchmark. So you have to know what that elevation is before you do a backside. The foresight is another rod reading. And this shoots towards a new station, sometimes called a turning point. Or other unknown elevation. So the foresight is the reading, a rod reading, and you shoot towards an unknown elevation or station. So this is the guy holding the rod at a new station point, and or we could call it also a TP or turning point. And that is your foresight. The station is the point where the rod is held. Okay, that's a station. And that is for reading, where the rod is held for reading it. And then
At the STN?
That's the STN, yes.
Okay.
That's correct. And now the turning point or the TP. So this is FS, STN, TP, BS, BM, BM, and HI. The turning point is used to establish
Foresight is TS or is that the FS?
that's F. FS, sorry, that's an F.
Okay, no worries.
I can't draw in the lines. I'm just a little messy. So the turning point is used to establish a new height of instrument in a new area. Okay, the foresight or the turning point. And sometimes we can call this a new benchmark. Temporary benchmark. When we need to move our instrument to a new location, say our pipe turns a corner and goes down another road, we have to move our instrument to get new readings. And now we're going to do some readings here. Now, this is a table, and this is a survey table. And this table is used to put in our elevations, our back sights, our height of instrument, our foresight. It is to keep everything in a kind of an orderly fashion, so we don't have numbers all over the place and not understanding what it is that we're doing. So I will give you guys one of these tables when we do our site surveying on SAIT campus. So when we're in campus doing our shop for builders level, I will give you one of these sheets so you can fill it out accordingly with your own observations. Now, the first thing we do is we start with a known benchmark. Yes, BM stands for benchmark, and this is the benchmark. So at this location, let me just squeeze this down just a little bit more, and then I'll increase the size of this. We're gonna have to, hang on. I got this, I need to shrink it. No, that's the way it is. Okay, so this is our benchmark here. And we see it's right here. So under the benchmark, you go where it is gray, you do not fill in. There is no numbers where it's blocked out. So we put our elevation right here, and our elevation is 672,680. And I got that right from there. And that's what we put in that number. That is going to be our bench mark. And so we will set up our builders level. We're going to set it up at a location so we can see the benchmark. So we have a line of sight to the benchmark, and we have a line of sight to our new foresight. You may not know where that foresight is yet, but that's no big deal. But we need to set up your builders level in a location where we have a line of sight at the benchmark. And your partner is going to be at this point, at this station at the benchmark, holding the rod. And you're going to, after you level your machine, you're going to take a shot. And this shot is called the back sight. This is your first shot. And you look into there and you read the rod, and it comes out to 1.765. And that's going to be your back sight right there, right? So now we can determine our height of our instrument. And I told you the height of the instrument is calculated by taking your benchmark and adding your back sight to it. So let's do that. We're going to take our benchmark and we're going to add our back sight to it so we can get our height of our instrument. And if I do my calculation, let me get my calculator out here. You should have your calculator out as well. And that comes out to 674.445 is the height of my instrument. Okay, are you with me so far? Is everybody okay? Now, once we have that, we can determine the elevation at the turning point 1. So we're going to call that turning point number 1 right here. And the turning point 1 foresight, this is the foresight, this number right here, the foresight is 1.233. So you're going to swivel your builder's level around to a line of sight to a new location. And now, because we have the height of the instrument and we have the foresight, we can get the elevation of turning point 1. And to do that, we take the height of the instrument and we minus the foresight. And that would equal our turning point. So we take the height of the instrument, and that was 674.445, and we minus the foresight off of it. So my elevation at turning point 1 is going to be 673.212. And now I have a new known elevation. Okay. So at this point, your person holding the rod at this station stays there, stays at that point. They don't move. We determine what that elevation is. We have it right there. This person does not move, but then the person moves the instrument to a new location. And once you move the instrument to a new location, you can now take a back sight. And underneath the back sight right here, we take a new reading, and that is 2.197, as it indicates right here. And with that number, we can determine the height of the instrument by taking, we know the benchmark plus the backside. So our new benchmark is right here. It's a 673.212, and we add 2.197 to it. $2.197. And that number comes out to 675.409. And that is my height of the instrument right here. That's the height of the instrument. And now we want to then shoot station 1. So at this point, once we determine the height of the instrument, the rod guy will walk over and then put his rod to a new location, a new station, if you will. And we can call this station 1. And now, once he's at that location, I turn my instrument and I take a new shot, and that would be my foresight. So under here, my foresight is going to be 1.185. So that's what that is right there. And now, because I know the foresight, I can determine the elevation at station 1. And how we do that is we take the height of the instrument and add the foresight. And that's going to be my turning point or station. So height of the instrument, 675.409. And we minus 1.185 off of it. And this new elevation at this point right here is 674.224. So now we have this elevation, this new elevation at station 1. We determined what that is right there. We will then move our instrument. So now the instrument gets moved. The person at station 1 stays there. They don't move. You move the instrument to a new location. And once you have your new location, you're going to take a back site again at station 1. So station 1 back site right here, it says 1.427. And once we got that written down, we could find the height of the instrument by taking our new elevation and adding the back site to it. Our new elevation is 674,224. There's our new elevation, and we're going to add our back site to that. Plus 1.4. And this becomes the height of the instrument with 675.651 is now the height of the instrument. Right here is right here. Once we have the height of the instrument determined, we will then take a foresight. So this person has to walk over here, and he's not happy anymore because he has to keep moving. We take a foresight right there. So we'll take this shot of the foresight. On here, it tells me it is 2.265. And once we have the foresight, we can get the new elevation at this TP2, which we will call this TP2. And our new elevation is calculated by taking the height of the instrument and minusing off the foresight. Height of the instrument, 675.651 minus 2.265 gives us 673.386. That is our new elevation there. Right here is right there. It's our new elevation. So once I have my new elevation at a turning point, I move the instrument to a new location. And then I take a back sight right here. And that back sight says it's 1.143. And now I can determine my height of instrument by taking a benchmark and adding my back sight. We have a benchmark, 673.386, and add my back sight to that. And that comes out to 674.529. And now that I have this new elevation or this height of the instrument, I got this guy moving to a new station, and he's happier now because it's almost over. And we take a foresight at this new benchmark 1. That's what it says here. So we'll call it that. I don't care. and we take a foresight of 1.862. That's this number right here. And then we can determine the new elevation of this benchmark. And that is done by taking the height of the instrument, mining off our foresight. So we have the height of the instrument minus off our foresight. And if I do my math correctly, that is 672.667. Okay, so now we have this new sheet. And this one, it looks like it's in imperial measurement, which is awesome. So we're going to determine all of these stations and benchmarks. So we have a benchmark 2 and we have a benchmark 1. So we are given an elevation or benchmark of 100. So that's here. That's 100 feet. It's given to us already. It is a known elevation. So we want to go all the way around and close the circuit and see if we can do that. So first thing we do when we set up our instrument here, we're going to take a back sight. And the back sight on this one is 8.45 feet. And then we're going to determine the height of the instrument. I told you that the height of the instrument is calculated by taking the benchmark and adding the back sight to it. So the benchmark is 100 and the back sight is 8.45. So this clearly is 108.45 feet. And now I'm at turning point 1. This is where this fellow is standing here with the rod. They move to a new location with the rod, and now they're over here at a new station. And then I take a foresight with my builder's level, and it says the foresight here is 6.45 feet. And now we can get the elevation right here, the elevation of this turning point. And I told you before, to do that is take your height of your instrument and minus the foresight, and that will give you your turning point elevation or new benchmark, whatever you want to call it. But this is TP1. So this is height of an instrument minus off the foresight. That is clearly 102 feet. That would be, Brett, that would be an architectural elevation or a given or known elevation. Okay, so they're just giving you 100 to start from. Does that answer your question?
Yep, thanks.
So now we have our foresight done. And at this point, this operator now, he moves his instrument to a new location. The dude with the rod at turning point 1 stays there. They don't move yet. And now at this location, so I have a new spot for my instrument. I take a back sight right there. And the back sight at turning point 1 is 7.45 feet. Well, Geez, you got, yeah, add, subtract, add, subtract, add, subtract. That's exactly right, Dustin. And benchmark 2 is 102.54. Thank you for that, Connor. I'm glad you got this down. That's fantastic. So the height of the instrument, as we know, is taken the benchmark or the known elevation, and we add the back sight to it. So this is the new known elevation. We're going to add the back sight to get the height of the instrument. So that's going to be 109.45 feet. So this now gives me my height of the instrument. So now this guy can move with the rod to a new turning point, or sometimes called station. And we have it here as a station 1. And we can then take a foresight. The instrument stays put while the rod reader moves. And then we take a foresight right here of 4.50 feet. And now we can get the elevation to this, where we take the height of the instrument and minus off the foresight, which gives us 104.95 feet. Now we have a new elevation. So the rod guy stays put while you then move your instrument to a new location. And once you've moved your to a new location with your instrument, you take a back sight at that station. And the back sight says here, 7.69 feet. Once we have the back sight, we can get the height of the instrument, where we take the elevation, the new elevation, and we add the back sight to that. And if I do my math correctly, that should be 112.64 feet. And that is my height of my instrument right there. Now the rod holder can move, and he moves, and now we have a foresight. And he moves to a new turning point, and they call it number 2 here. And I get a foresight of 6.58 feet. And now to determine this elevation at turning point 2, we take the height of the instrument and minus off our foresight. And if my math is correct, it's 106.06 feet. Now I have this elevation. The rod guy stays there, and I move my instrument to a new location. Once I move my instrument to a new location, I can take a back sight at TP2, and that tells me it's 2.98 feet. And now I can determine the height of the instrument by taking the known elevation at TP2 and adding my back sight to get my height of instrument. And that should come out to 109.04. Now my rod guy can move to a new station, and actually we're going to call that the benchmark 2. So this is top of a manhole, and we'll take a foresight, and that foresight is 6.50 feet. And to get the elevation at benchmark 2, we simply take the height of the instrument and minus the foresight. And this should come out to 102.54 feet. So if we were to find the difference in elevation from benchmark 1 to benchmark 2, we know that the elevation at benchmark 1 is 100 feet. We simply minus it off. So the difference in elevation is 2.54 feet from here to there.